Hey guys, it's Christian with the Interactive Immersive HQ. Today I got a tutorial where we're going to mess around with LED matrices and connect our webcam and do some audio visual work and send that signal over to some LEDs and get real fun with it. If this is looking completely new to you or you've never worked with LEDs, we have a tutorial that I did a while back where I went over WLED on ESP32s and LED strips that we can control using TouchDesigner that I'll link down in the description. All right, getting off to a good start here. This is the setup that we're going to be working with. I have a breadboard, some breadboard wires right here that are connected. I have my ESP32 right here, a 5-volt power source that's going to be powering our LED matrix over here, as well as our ESP32. This is an upgrade from the original setup that I showed you guys in the previous tutorial, which was me just connecting it and using the power source from my laptop to the ESP32 and powering the LED strips. You can do that. It's not going to be super powerful. You might get some voltage drop that's happening across the matrix, but this is a good one. Usually they'll come and give you guys the ability to do some power injection, and then that's what these two wires right here in the back of this. So if we're finding that our matrix is getting a little dim halfway through, 3/4 of the way through, we can inject power into it and make it so that our LEDs are the brightest they possibly can be. So the main difference between the circuitry that I have going on here and the one I used last time is that we're actually going to have to use the breadboard to power our ESP32. So I have our ground breadboard wire and our voltage breadboard wire, and they're both going into their respective places on the breadboard, the positive and negative channels. And also I have this white ground pin and this red voltage in pin that's feeding into the LED strip, as well as the green wire that's the data coming from the GPIO 2 pin right over here. Otherwise, it's pretty straightforward. We take our voltage, our 5-volt power supply, and I'm going to use this red pin, or red breadboard wire connected to the red wire on our power supply, and this yellow breadboard wire is going to go into the ground pin, and I'm going to plug that in, and everything should be working for us. Our ESP32 is getting powered, our LED strip is getting powered, and this right here is our WLED portal that's communicating with our matrix. I have the IP address right over here that's connected to my local network. I'm going to go into config and LED preferences, and as you can see, this matrix is 8x32, which is going to give me 256 total LEDs that I can work with. The GPIO pin is 2 that's connected onto my ESP32, and we can go ahead and use this and communicate with it through TouchDesigner. So in our fresh TouchDesigner project, I'm going to go ahead and drop down a ramp, and we're going to make this 8x32, which is the same resolution as our LEDs. 1 pixel is going to correspond to a single LED. Then I'm going to feed that into a chopped or top 2 to convert into chop data. I'm going to take out our alpha. I'm going to set output as single channel set to on, and go to crop and go full image. And the previous setup, I fed that into a shuffle and had to kind of disentangle the chop data that I was getting in. This is a little bit of a faster solution for that. We're going to feed that into a shuffle, choose sequence all samples, and I'm going to connect that to a math and set the range to, I don't want to blow out the LEDs, so let's just do 150. And just for the sake of sanity, I'm going to put that into a limit and clamp these values such that it's going to correspond to our range values. That way that we're not going to get anything outside of the 0 to 150 point range. Then we're going to go ahead and drop down a DMX out chop. We're going to set this to SACN, packet per channel, the network The network is going to be what I have in my browser window on the WLED portal. I'm going to delete these dashes and web addresses and open our table right here and make sure that the channel name over here corresponds to what we have. 0 on the net, 0 on the subnet, and 1 on the universe. And we're good to go. We're getting some signals. This will send only once if we're not animating it. And so we can see things are appearing, but there's a little bit of finickiness happening here. We actually have some dead pixels. Nothing's happening over here. And then the ramp isn't quite coming through. It looks like there's a serpentine pattern. That's telling us that the matrix is actually, the LED addresses are serpentine. So we're sending a signal to the first row, but then it's switching direction on each subsequent row. And if we want to fix the first one, what we need to do is see that the DMX channels can only handle 512 addresses. So we'll need to split our channel into 2 different universes to cover the entire 256 LEDs. So we're going to take this and we're going to choose the method as split n samples. And I've put n value of 512 over here. So we have our first 512 channels or samples, and then our remaining ones, it's filling in the rest. So it's giving them whatever holded value is the last sample in the channel that I was giving. I'm going to plug that in. And now our channel name has changed from R to R0 and R1. So we'll start our first one with R0 as our first universe, and then R1 is our second universe. It's also going to be 0 on the net and subnet, and then 2 the universe right over here. So now we can see there is some mismatching of the LEDs. It looks like we're not combining the red, green, and blue channels to get a pure white. If you can see that, there is a little bit of a red. And if we go and change this to 510, that will fix it. And the next problem we have over here is this serpentine pattern. And what's nice in WLED is that we have this option for 2D configuration. And right now I have a 1D strip, and we can do that, but we would have to package the data in a different way. I'm going to go ahead and click 2D matrix. We have 1 panel, and the dimensions are 8 by 32. And we have this option right here to choose serpentine. If I go ahead and press save, that fixes it. And so now we're getting the correct data that we're sending from TouchDesigner to the LED strip. So now that we have our test set up and running, it's successfully sending data over into our LED matrix. We can use this top over here as a template to build off from and use as our jumping off point to create effects. And the first one I want to do is a webcam effect that we're going to send video from my webcam over onto the LED. So I'm going to go ahead and choose video device in. I'm going to feed this into an NVIDIA background. This is going to isolate me in the view, and I'm going to feed this into a matte. This is going to go in the bottom, and then what I want to be the background is going to be in the middle. And I want to turn all of this off because I don't want anything other than my figure, so I can distinctly tell what I'm doing in comparison to any of the background. So out of the matte, we're going to feed this into a fit. And I ultimately want to take my video input and translate it into an aspect ratio or a resolution of 8 by 32. So we're going to go over here into this resolution tab, choose 8 by 32. And the first thing that you're going to notice is that obviously it's really pixelated, but this isn't fitting what we need it to. And one way for us to make this a little easier on ourselves is dropping a fit over here, and we're going to make a square aspect ratio because I'm going from 1280 by 720 to something that's just 1000 by 1000. And we want to stretch it across the LED so that it's actually going this orientation. So I can switch this to a 90-degree rotation right here. And you can see, here's little old me in this fit. We can go fit vertical. And it's getting a section of my webcam just because 8x32 isn't the 1280 by 720 aspect ratio, but this is going to work for what we have. If you have an LED matrix that's higher in resolution, 32 by 32, 16 by 16, then we can have something that's a little bit more true to form to the video input that we're getting. But for now, we're going to feed this into a threshold, drop this down to like 0.67 so that we're successfully converting all the colored pixels that have a non-zero alpha into pure white. So going back to our LEDs, we see we still have the ramp that's smoothly transitioning across the vertical portion of our matrix, or horizontal, however you want to see it. If we plug in our threshold, making sure that it's the same aspect ratio, you can see that now I'm showing up on the matrix. We can see my hands, you can see my figure. It's actually flipped right now, so we can reverse and go -90 in the horizontal, and now we're getting the correct orientation for my body. And an additional tip that we can put onto this, it's a little bit, sometimes it can be a bit jarring to have completely off pixels right next to completely on ones. It gives a little bit of a jittery feel, especially if I take this threshold off. We can see that we're getting some flickering. The pixels sometimes have a hard time working with really small values. So I plug that back in. We can feed this through a feedback network. Drop down a feedback, level, very standard feedback system, comp. Plug this in, choose over, feed this back, and we're going to go into post, change the opacity to like 0.8, something so that we get some fall off. If we look over here, there's some nice kind of trailing that's happening to my figure. And if I plug this back in, we get a little bit slower motion, but it's a nicer transition between the black, the purely off pixels, and the purely on ones. Obviously, it gives a little bit of a slower, sort of less responsive. It's introducing latency into the system. If I wanted to make it less so, we can just drop down the opacity, and we're getting closer to the original network. And so this is something that we can tweak based on the look and feel of what we want it to do. In addition to this, we can also change the colors that we're using over here. So if I go ahead and plug this into a constant, I'm going to put the output, make sure that it's multiply so that whatever color we assign right here is the color we get and we're assigning. So let's go with like a blue. And if we plug that in, we can see that we're getting a much more saturated, much more bright blue. I can change this and bring down the saturation a little bit, maybe make it kind of green. It's a little bit harder to see on the what's recording it right now. Maybe if we go red, kind of looks like a little pink, more red right here, or go with yellow. And then I can pull this down into another constant. And I'm going to put this onto over. Actually, it should be under. And we can change this to maybe a blue underneath so that we're getting a blue background with a yellow figure. It's something that we can see from what I see right over here. There's a nice contrast between things, but because it's so bright in the top-down view. It's a little bit harder for you guys to see, so I can bring down the brightness on the alpha, which is going to change how bright the RGB values are as well. We could bring it down a little bit more. And so you can see my figure coming across, and we're successfully transmitting what's the input that I'm getting from my webcam over into this LED matrix over here. So the next effect that we can use is an audio device in or an audio file in and make a little audio visualizer using our LED matrix. And the first thing we want to do is get in an audio file. And I'm going to feed this into a math. Combine channels, we're going to average them just because we don't need a right and a left. And for sanity, I'm going to do audio device out. And you can hear that some music is going, the default TouchDesigner famous track that everybody's heard a million times. I'm going to bypass this so you don't have to listen to it. And I'm going to feed this into a spectrum chop. And this is giving us our audio spectrum. It's something like 22 or 2,000 samples in our channel. It's just way too many for us to do in our LED matrix for us to see any sort of distinction. But I'm going to feed this into top, and we have our data format as the R channel. But I want to change this because this is just a mono. I want to change this to 32-bit float. So now the audio channel is being converted to our red channel. So from here, I actually want to make it so that we're getting a white channel so that we can accurately, just like our last network, we can change the color however we want. So I'm going to, on this red column, put white on everything. So now we see our top is purely white, and we want to fit this. And we're going to make this 8 or 32 by 8. This is the wrong orientation, but this is going to more easily let us convert this over. And we're just going to have to flip this after we do it. So we're going to hit this on a fill. And if I press the display active and then I press D over here, we can see the values that we're getting in. And so we're getting a nice fall off from these peaks on the audio spectrum. And it's going to look nice. This is sort of almost a pre-visualization of what we're going to end up seeing in our LED matrix. But from here, I'm going to go ahead and pop this over into a fit as well. And then just switch our orientation and then rotate it 90 and then press fill. And so we've correctly flipped this over. Now we come to, again, we have our LED matrix and it's being fed our template. And all we have to do is just pop this over, and we can see that we're getting the audio visualizer that's happening on our LED matrix. And if I go ahead right here, now you can see that the LED is lighting up based on the audio that's coming in, and we can mix and match. Turn down the volume a little bit, and I can pull this and do the same sort of constant trick that I had before, making sure it's multiply. We can have red instead. We can also change this to blue. We can have yellow. We can sort of mix and match here. The one problem that I see that we can't more easily do is we can't have a good background on this, because these values right here are pure black and the alpha is pretty much close to 1. And so we can't easily comp over the background here. So what we'll have to do is do our little threshold trick. This gives us what values are coming in. I want to kind of bring this down a little bit more, just like we had before. Then we can bring this up. then we can pull this into a constant as well. Make this red or something. Put it under. And then now we have a full visualizer happening right in front of us. Well, that's it for us today, guys. Hopefully you enjoyed and learned something new and can make something fun and creative with your own LED matrix.
Hey folks, thanks for watching. If you like our YouTube content, I highly recommend you check out the Interactive and Immersive HQ Pro. The HQ Pro is the only comprehensive educational resource and community for immersive design, TouchDesigner, and creative tech pros. In the HQ Pro trainings, we cover almost any topic you can think of, and we go way more in depth than we do in our YouTube tutorials. We have a private group where Matthew Reagan, myself, and our other industry veteran and pioneer teachers answer your questions every single day. If that sounds cool, click the link in the description to learn more. And if you enjoyed this video, hit that like button and don't forget to subscribe for more free TouchDesigner and immersive content.